really cool. Extinction may not be the end of the line for some species.
Scientists are now trying to bring back some of them decades after they actually disappeared.
What we're talking about is bringing back animals that were once extinct by using genetic engineering. We all saw in Jurassic Park dinosaurs brought back to life. Now science has almost caught up with science fiction. And de-extinction, as it is called, isn't that far-fetched.
Continuing my work in telling the tragic and amazingly hopeful story of the Tasmanian tigers, I attended a conference on bringing back extinct species. As was suggested to me by the man who now holds the jar containing the thylacines Hope for a New Future. His name is Professor Mike Archer. He is head of the project to restore the thylacines, which, if successful, would complete an amazing narrative of mankind's growth of moral awareness and of ability to master the elusive inner workings of nature. Moreover, it would rewrite a grave past wrong. So I journeyed to the main building of the National Geographic Society in Washington, D.C., a stone's throw from the White House. On my way from my hotel, I passed by the Embassy of Australia and this monument to the great 19th century orator Daniel Webster. For me, as a nerdy and awkward teenager who learned to talk in speech and debate club, this was a significant moment for me. I then made my way to the Gross Venter Auditorium where Professor Archer would be speaking. The Tasmanian tiger, it turns out, is not the only species with a chance to live again. Scientists have collected DNA from the preserved tissues of other species too, especially in the frozen north. There was a huge poster on the wall showing this photo of the thylacine. I made my way in and took a seat. Professor Archer outlined the accomplishments of the thylacine project to date, emphasizing that this animal was not just a unique species, but a unique family. The woolly mammoth and the Carolina parakeet may be extinct, but we still have elephants and parakeets. There was nothing else quite like the Tasmanian tiger, and we humans are directly responsible for their demise. Professor Archer said that we therefore have a moral imperative to try to bring them back, and has said that they were exterminated in an ungodlike manner. He said, moreover, that recovered thylacine DNA had been activated in mice, thus demonstrating the soundness of the principle that genetic material from the Tasmanian tiger can indeed be reactivated. He also related the story of his visit with an elderly man in Tasmania, over 90, who, as a boy, hunted and trapped thylacines with his father. The two of them trekked to the spot where their hunting cabin stood. The elderly man said that during the night he remembered the thylacines walking around the cabin, checking it out, and making high-pitched vocalizations to each other, something like a yip-yip sort of sound. As a boy, he put a collar on a thylacine and walked around with it on a leash like a dog. Mike Archer expressed his amazement with the concept that, somewhere in the neural connections of this elderly man's brain, were vivid memories of living, breathing, vocalizing Tasmanian tigers. The Human Genome Project was completed some time ago. A genome is a complete record of all of an animal's DNA information, and now scientists are sequencing the genomes of all sorts of animals. We now have new tools and new machines for doing this. Speakers referencing the woolly mammoth mentioned the option of filling in gaps in the mammoth's genome with elephant DNA. The same could be done for extinct birds. The thylacine may be more tricky. The thylacine genome could benefit from the DNA of this creature here from New Guinea called a quoll. I had lunch with a French geneticist who expressed skepticism as to the feasibility of the entire enterprise, but my reaction was that we now have powerful new technologies for gathering and analyzing information. The same Google technology that sees the whole internet at once and matches it to your keyword can also see an entire genome all at once, and powerful digital microscopes are able to record what's going on deep within cells. which humans and powerful new software can then analyze. The workings of life are, at base, quite similar in all living things. A human's genome is only about 1% different from that of an ape, and a mere 10% different from that of a microscopic bacteria. In time, it should be possible for us to understand what changes cause what differences, and how nature got from a tree-dwelling marsupial like a quoll to kangaroos, wombats, and Tasmanian tigers in the first place. Finally, what makes the thylacine so remarkable and makes me so motivated to communicate about it is that it is a powerful example of convergence in nature. It's as though the concept of dog or canine is somehow written into the laws of nature themselves and can emerge through completely different evolutionary pathways. Astronomy has long ago determined that the Earth's place in the universe is completely ununique, meaning that there can be many, many Earth twins out there. Astronomers are right now honing in on small, rocky, watery Earth-like planets, and it may be that the concept of human being is likewise written into the laws of nature, and that possibly, somewhere out there in the depths of space, there are other human-like beings and other dog-like beings.
Played the devil by causing these species to go extinct. So in that sense, playing God to bring them back might be the right thing to do.